Hi, in this video, we'll be talking about the basics of dictionaries. A dictionary is an unordered set of key-value pairs. The features of dictionaries. Dictionaries are mutable. They can be changed, shrink, or grow. Dictionaries are defined in curly braces. Dictionaries can contain lists. Dictionaries can be contained in lists. The elements in a dictionary are accessed by keys and not by indices. The keys in a dictionary are unique. Each key is mapped to a value. The values may be any data type. The keys may be only immutable data types. Dictionaries don't support the sequence operations of lists, tuples, and strings. Dictionaries are the only representative of the built-in mapping type. Let's define a dictionary. In each pair, the first element is the key and the other is a value. The two are separated by a colon. Have a look. Let's make it smaller so that we can see it better. So this is our dictionary. It's defined in curly braces. It contains the following elements: a key-value pair, another key-value pair separated by colons, another key-value pair, another key-value pair, and one more. So there are 5 key-value pairs, so 5 elements in this dictionary. We access them by key. So, countries, capitals with key Norway. And we get Oslo. So here we have the key, and this is the corresponding value. If we use a key which is not contained in a dictionary, we get an error. Let's try to access the element with the key Nigeria, which is not in the dictionary, and we get a key error. If we try to access an element by index, we get an error too. Dictionaries are unordered. Indices don't work. So let's try to use an index 1, for example, and we get an error because this is treated as a key and there is no key with this value in the dictionary. In order to add a new entry to a dictionary, we use a new key and set its value. So, for example, we would like to add Austria and its corresponding capital, Vienna, to the dictionary. We can do it like so. Countries' capitals with key Austria is equal to Vienna. And now if we print our countries' capitals again, we can see that Austria, Vienna, has been added to it. In order to change a value in a dictionary, we assign a new value to the key. Let's create another dictionary, a simple one, scores, with 2 elements. The first one has the key Tess and the value 17. The second one has the key Jackie and the value 22. Now let's change the value corresponding to Jackie to 35. We can do it like so. Scores with key Jackie equals 35. And now if we print scores out, this change will be visible here. We can create an empty dictionary by using an empty pair of curly braces. So, scores equals, this is an empty dictionary. We can check it out. As you can see, it's a dictionary. And now, if we print it out, we get an empty dictionary. And then we can add elements to this dictionary. So, scores with key Amanda equals 246. Now our dictionary already contains one element, a key value pair. The keys must be unique. If we try to define a dictionary with repetitive keys, only the last value will be selected. Have a look. Let's make it smaller so that we can see it. Fine. Here we have our first name dictionary. And here we have Smith, Peter. This is a key value pair, so the first element of the dictionary. Jackson, Luke. And now here we have Smith, Natalie, Smith, Patricia, Brown, John. So Smith, this key occurs 3 times. Here, here, and here. And now, look what happens if we try to print it out. So, first names. So it turns out that only the value Patricia, which is the last one here, was assigned to this key. So here we can see that keys must be unique, or we'll lose the previous values. Only the last one will be maintained. Now the values don't have to be unique. Have a look at this dictionary. Birth months. Here we have keys: Janet, Julia, Ron, Emma, and Louise. They are unique, so okay. But how about the values? We have March, October, March again, June, and June again. Now the values don't have to be unique, so this works as expected. Birth months. Everything is still here. And now we can check, for example, the birth month of Janet. So birth months with key Janet. And we get March. Or birth months with key Ron. And we get March. The values can be simple or complex data types. Here's an example with the values being other dictionaries. So here we have a dictionary which contains 3 elements, 3 key value pairs. The keys are strings: math, programming, and physics. And the corresponding values are dictionaries. So here we have dictionaries inside dictionaries. Dictionaries used as values. And let's print it out. Lectures, and this is what we got. A dictionary in which the values are other dictionaries. And here's how we can access a value inside the inner dictionary. For example, lectures with key physics with another key lecturer, and what we get is Louis' particle. So lectures with index physics gives us this value, this dictionary, and then inside this dictionary we get this key lecture, and the corresponding value is Louis' particle. We can use the values in one dictionary as the keys in another. Here we have 2 dictionaries. The English-German Fruit Dictionary and the German-Spanish Fruit Dictionary. As you can see, we have keys and values being strings in these 2 dictionaries. And now, in the first dictionary, we check the value of apple, which is Apfel. We can do it like so. English, German with key apple. And we get Apfel, which is the value corresponding to this key. It so happens that Apfel is the key in the second dictionary. So we can find its value either like so, German, Spanish, and we get manzana, or like so, German, Spanish, and then as the key we can use this, English, German, apple, and we also get manzana. We can create a dictionary of dictionaries. Have a look at this. Fruit dictionaries equals. Here we have a dictionary of dictionaries. This is a dictionary and this is a dictionary. These two dictionaries are used as values. And how can we use it? Now we can find the word we need in the dictionary we need. So let's see in the German-Spanish dictionary, what's the Spanish for orange? So fruit dictionaries, in the German-Spanish dictionary, we want to check this word. And this is what we get, naranja. The keys must be immutable types. If we try to use a mutable type, like a list or another dictionary, you'll get an error. Have a look. We're trying to define a dictionary in which the key is a list. Well, this doesn't work. We get an error. Lists are mutable. They can't be used as keys in a dictionary. But you can use a tuple. So instead of defining this as a list, we can define the key as a tuple. And this time it works. A tuple can be used as the key. But you can't use a tuple which contains mutable types like lists. For example, this doesn't work because although here the key is a tuple, but it contains a list, which is a mutable type. We can use the len function to determine the number of key value pairs. Let's have a look at this. And now let's use the len function to determine how many elements there are. 4. That's right. Using the in and not in membership operators, we can check whether a key is contained in the dictionary. So let's check whether shark is contained in the dictionary. Shark in animals. True. How about ladybug? Not in animals. And this is also true. We can delete a key value pair using the del keyword with a key. So let's try to delete this element. We can do it like so. Del animals with key wasp. Now, this element is no longer in our dictionary. We also use the del statement to delete the whole dictionary. So, del animals. Now, animals is no longer there. We can keep the dictionary but clear its content using the method clear. So let's define another dictionary, capitals, and now let's clear it. Capitals, clear. And what we get is an empty dictionary. Okay, that's it for this video. If you like it, a thumbs up would be great. Also, make sure to subscribe for future videos. If you want to leave a comment or ask a question, you're welcome to do so. Thanks for watching.